Okay, so in this video tutorial we're going to be talking about units and converting from non-SI units to SI units and then units within the SI system itself. So first of all, SI stands for System International. So it's the metric system. So we have some base units that fundamental units that we're going to be talking about throughout the year again and again and again, and then we actually have what's referred to as derived units. So we have derived units down here. So the four units that are fundamental is length, mass, time, and current. So for length we have the meter. For mass, the base unit is the kilogram. It's the only base unit that actually has a prefix in front of it. For time we have the second. And for electrical current, we have the ampere, or the short notation of that is amp. So for letters, we use lowercase m. We have kg for kilogram. For second, we have lowercase s. And then for amp, we have capital A. And then derived units are basically a combination of the four above. Oh, by the way, there's actually 7 fundamental units. But we will only be talking about 4 of them. And then the derived units are combinations of those 4 units. So for speed, we already discussed a meter over a second. For acceleration, we have a meter per second, or often noted as meter over second squared. For force, we have the unit called a Newton, named after Sir Isaac Newton. And we will write it with a capital N. And then energy, something that you probably remember from chemistry, is the unit of a joule, noted with a capital J. And so these are all combinations of the fundamental units. So it turns out that a Newton is a kilogram times a meter divided by a second squared. A joule is a Newton times a meter, which works out to be a kilogram meter squared over second squared. So notice that even though this is called a joule, it's really just a combination of kilograms, meters, and seconds. And so rather than always calling it a kilogram meter squared over second squared, it's useful to have it derived to be something else, named after a physicist as well. So we will be, on occasion, converting in and out of the metric system, and these will not be numbers that you need to know off the top of your head, or a few of them you already know, but miles to meters, there's a little over 1,600 meters in 1 mile. There are 2.54 centimeters in an inch. There are 60 seconds in a minute, and there's 60 minutes in an hour and 60 seconds in a minute. So there's 3,600 seconds in 1 hour. And in all these scenarios, 1 mile equals 1,609 meters, and so on and so forth. So in your reference table, you have a page that looks like this. And it says the prefixes for the powers of 10. So there's all these prefixes, okay, tera, giga, mega, and so on. And then there's the symbol used. And I just will make a note about capital M, meaning mega, 10 to the 6th, or a million, and milli being lowercase m. So just be mindful of this. Watch out for this when you're working through conversion. If it's a capital M, then we're dealing with a number greater than 1. And if it's a lowercase m, it's a unit less than 1. Okay, so let's move on over here and talk about the prefix system. So what I have here is 1,000 meters. Now I'm writing this in scientific notation, so I'm moving it over 1, 2, 3. So it's 1 times 10 to the 3. And then I look at the power of 10 chart and say, okay, well, what is 10 to the 3? And if you look at that chart, you'll see that kilo stands for 10 to the 3, and kilo has the symbol of lowercase k. So I could write this as 1 kilometer or kilometer. Okay, so what I'm doing is replacing 10 to the 3 with the letter K. Okay, likewise, 1, 2, 3, 4, 5, 6. I could write this in scientific notation as 1 times 10 to the minus 6, because it's less than 1. And if I look up on that chart, I can look up 10 to the minus 6. It stands for micro. Micro has the Greek letter mu. Okay, so I could write this as 1 microsecond. Now, in this case, I want to first put it in scientific notation, and then I want to replace the power of 10 with a prefix. So, first, I'm moving it over 2 places to the right. So this is 5.4 times 10 to the minus 2 meters. And then if you look up what does 10 to the minus 2 meters represent, that is centi. So I could write this as 5.4 centimeters. 3 kilojoules. That kilo stands for 10 to the 3, as mentioned before. So this can be expressed as 3 times 10 to the 3 joules. Once again, I'm replacing K with 10 to the 3. Or if you want to expand this out, this is 3. And then we're moving the decimal over 3 places so we could fill in 3,000 joules. All right, and if we want to do some conversions, okay, we have a sea turtle swimming along at a rate of 1.4 miles per hour. Now, you've probably seen this before on speed limit signs, something like that, MPH. We're going to write it at like this, miles over hours, or miles over hours. And it's really important because what we want to stress is that miles is in the numerator, and hours is in the denominator. So right now we want to convert it into miles per hour to meters per hour. So I want to get rid of the miles and put it into meters. So I set up a conversion factor, and I have miles up top, so I want to put miles down below in the fraction. I want to get it into meters. Notice, by the way, that if I'm writing meters, I'll just use M, and if I'm writing miles, I'll spell out miles. And that's just because we'll be using more times than not, we're talking about meters and not miles. And 1 mile is 1609 meters. And mathematically, miles divided by miles cancel out, and now I'm left with a unit of meters over hours, which is what I wanted. So what do I do in my reference, my calculator? I take the 1.4, I multiply it by the 1609, and when I rounded this to the whole number, I have 2253 meters per hour. But that's a number that's hard to conceptualize. So let's convert it to meters per second. So now I have the 2253 meters over hours, and I want to get rid of the hours and get it into seconds. So I'm going to put hours on the opposite side of where it currently is. So it's currently in the denominator, so I'm going to put it in the numerator. And 1 hour is 3,600 seconds. So now hours cancel out. I am left with meters over seconds. And now what I would do in my calculator is 2253 divided by because it's in the numerator, the denominator, and divide it by 3,600. And when I worked that through, I got 0.63 meters per second. And if I take a look at the 0.63, this actually will be true all the time, that we have 1.4 originally, and we have 0.63, a little bit less than half. So 2 miles per hour is approximately equal to